morning. My name is Sudhakar. I am going to teaching about the basic manufacturing technology. In that, we are discussing about the lathe machine and its operations. Right. So, before going to start today's class, yesterday we have learned about the some of the work holding devices. Right. Can you recall now? That work holding devices are checks, right? Mandrels, lathe centers, lathe dog, etc. In that work holding devices, we are started with the checks. In the checks, we are having 5 types of checks. One is 3-jaw universal check. Second one is 4-jaw independent check. And the third one is magnetic check. And fourth one is universal check. Sorry. The fourth one is manual check, and the fifth one is drill check. So these are the 5 types of checks we are having, right? In that 5 checks, we have discussed about the 2 checks. Those are 3-jaw universal check and 4-jaw independent check, right? In 3-jaw universal check, the 3 jaws are moved by single key way, right? So that's why it is called as a universal 3-jaw universal check. In 4-jaw independent check, each jaw is moved in and out by independent key. That's why it is called individual key. That's why they are called as 4-jaw independent, right? With the 3-jaw check, we are holding cylindrical objects and hexagonal objects, and with 4-jaw check, we can hold the objects like square, octagonal, right? With the 3-jaw check, we are not holding the irregular shape work, but with 4-jaw check, we can hold the irregular shape work pieces, right? So that's why we are discussing about these 2-jaw checks. One is 3-jaw check, and the second one is 4-jaw check. Compared to 3-jaw check, 4-jaw check is having more gripping power to holding the work pieces, right? Now we are moving to another device, that is magnetic check, right? So this is also one of the type of check that is called magnetic check. In magnetic check, it is hold steel workpieces. So the workpieces which are having uh, magnetic behavior, that type of workpieces, these checks are holding, right? So these checks are used to hold the steel workpieces. That workpieces made up of magnetic material, and that too they are thin to be held in an ordinary check. And the materials which are very thin, which are not easily held in the uh, remaining checks, which are not holding the remaining check, that are too thin workpieces. We are fixing that workpieces in magnetic check. So to fixing in this check, the material should behave as a magnetic material. Then only we can fix the objects in this check. Otherwise, we cannot fix the workpieces in this type of checks. Okay. So the material which are having magnetic behavior and the material which are too thin, not holding in another ordinary check, that type of workpieces are held in magnetic check, right? The face of the check is magnetized by permanent magnets. So this magnetic check face is magnetized by permanent magnets. So its face is fixed with the permanent magnets. So it is behaving like a magnetic material, and it is suitable for work that requires only light cuts. This type of magnetic chucks are not suitable for workpieces that requires only light touch. So we are using magnetic chuck material, magnetic chucks. So this is the magnetic chuck. So this is the ordinary material, and these are the magnetic materials. These are the magnetic materials. The materials which are too thin and not holding in ordinary chuck, not held in ordinary chuck. That type of workpieces are fixed in this magnetic chuck, right? So this is the magnetic chuck, and the next one is collet chucks. It is mostly used for holding bars of small size below 63 mm and used for production work. 63 mm size work pieces, size bars are used in uh, production work. That type of work pieces are fixed in collet checks, right? So the collet checks are used for below small size, very small size objects are fixed. It is in the form of thin cylindrical bushing with a slot cut lengthwise on its periphery. It is in the form of thin cylindrical bushing with a slot cut lengthwise on its periphery. We can observe these type of checks in the figure. Then only we can understand easily. The inside bore of the collet depends on the shape of the workpiece. The inside shape of that collet should be similar to the shape of the workpiece. Then only it can hold the objects, right? So these collet checks are holding the smaller objects which are not held in the ordinary checks. That type of objects are used in collet checks. The collet checks are in the form of thin cylindrical bushing with a slot cut and lengthwise on its periphery. The inside bore of the collet depends on the shape of the workpiece. Used for checking internal surfaces. So this is used for checking internal surfaces. So collet check inserted in a spindle. So this is the hand wheel, spin machine, collet, spin nose cap, spindle, drawbar, headstock. So this is the headstock. So here we are having spring machine collet. In that we are having the hole. So the spindle is having hole. In that hole we are fixing our thin jobs. The collet check inserted in a spindle. So these are the collet checks, right? We have learned so far. They are cylindrical in shape. Collet checks are cylindrical in shape, and they are having slots on its periphery lengthwise. Understood? These are in cylindrical shape, and they are having these slots on its periphery up to its length, up to its some length. Okay. So here we are having some gap, right? So these gaps are having some dimension, right? With that dimension of the object, they are holding. With that dimension only, they are holding the object. So we are fixing our small diameter jobs in this collets, right? In this collet checks. So this collet check is now directly going into the spindle. This end is fixed into the spindle, and in this we are fixing our job. Understood? In this we are fixing our workpiece. We are fixed. We have fixing our workpiece in this hole. So it may be expand with some distance, right? It may be expand with some distance. So with that expansion, it holding the object tight. With that expansion, it can hold the object tight, right? So after fixing this, this end is going into fixing the spindle, right? This end is going into fixing the spindle. Likewise, these collet checks are fixed in spindle. So this is the cross section cutaway view of the collet check. Here we are having the material, and this is the gap. This is called the slot. In this slot, we are fixed our object. Understood? In this slot, we are fixed our object. We are fixed our object, right? This section may be some expansion. It may expand some distance. After that, it can hold the object. After expansion, some distance, it can tightly hold the object. So that's why uh, these collet checks are used for fixing the small jobs, the jobs which are uh, not easily fixed in ordinary check. So collet checks may be used. The small jobs, the size should be minimum 63 mm length below or diameter below size jobs are fixed in collet checks, right? Once again, I can recall. It is mostly used for holding bars of small size below 63 mm, and it is used for production work. It is in the form of the collet checks or in the form of thin cylindrical bushing with a slot cut lengthwise on its periphery. The inside bore of the collet depends on the shape of the workpiece. The inside bore depends upon the shape of the workpiece, and it is used for checking internal surfaces also. This point is very important here. The inside bore of the collet depends on the shape of the workpiece, right? So whatever the shape we are having the workpiece, uh, we are using that shape of collet chip only. We are using that shape of collet chip only. Now we are moving to another check, the last check, that is drill check. The drill check is nothing but it is used in the drilling operation. It is used in drilling operation. Why? Because it is used for holding straight shank reamer or drills for reaming or drill. We have to fix our drill bit in lathe tailstock. In tailstock, to holding that drill bit, we need some some device for holding the device. For that reason, we are having this drill check. This drill check is used for holding straight shank reamer or drills for reaming or drilling operation. It has self-centering jaws and is operated by a key. So it is having self-centered jaws and it is operated by a key. The check key is held in the lathe tailstock. I have told already this point. The check key is held in lathe tailstock. Why? Because this check key is held in lathe tailstock because we are fixing our drill bit in this tailstock. So to holding tightly to that cutting tool, we need a holding device. That holding device is a drill check. So that's why the check is held in the lathe tailstock, right? So these are the drill checks. Here, this is the drill check. We are fixing this drill check in the tailstock. Here we have a key. By this device, we are fixing tightly in the tailstock. By fixing tightly in the tailstock, right? So these are the typical drill bits, drill holding devices, drill checks, not drill bits. These are the drill checks, right? These are the drill checks we are observed here. This is for tightening and loosening this drill check. This key is used for tightening and loosening the drill check. So these are all about the checks, right? These are all about the checks. So what are the types of checks? 3-jaw universal check, 4-jaw independent check, magnetic check, collet check, and a drill check. So these are 5 types of checks. In magnetic check, we are using for holding the thin materials which are not held in the ordinary object. That material should be in magnetic behavior, and the check is also behave like as a magnetic material, and in collet check the lengthwise the lengthwise is 63 mm below objects are not held in the ordinary object. So that's objects are held in collet checks, right? In drill check, we have to fix the drill bits in the tail stalk. So that's why we need drill check. In this drill check, we are fixing our drill bits in this drill check, right? So these are all about the checks. So by this we are completed only about the checks, right? And the remaining work holding devices are we are going to discussing about that. So that work holding devices are again I can recall them. Chucks, collets, driving plates, carriers, rests, mandrels, space plates. So these are all work holding devices. In that we are only completed the checks. The checks are magnetic check, collet check, drill check, right? 3-jar universal check and 4-jar independent check. Now we are moving to the another work holding device. Lathe centers, right? Lathe centers are the another work holding. Lathe centers, right? As of now, we are discussed about the checks only. Now we are moving to another tool holding work holding devices. They are lathe centers. We know we are well known about the centers. That is, one is at the headstock side and another one is at tailstock side. One is at the right hand side and one is at the left hand side. The right hand side is tailstock and the left hand side is headstock. So for long center job, for long length jobs. So the length of the job is very long. The type of jobs need to fix in the lathe machine. They need centers. They are compulsory. They need the centers. They are not fixed in the checks or any other devices. If we are fixing it any other devices, they are having vibrational effect by rotating. For that reason, we are providing centers for that type of jobs, for lengthy work pieces. We need centers, right? So one is at the right hand side and another one is left hand side. So though they are called as centers. So here, the lathe centers are hardened devices used for holding and locating the work to be turned between the centers. Lathe centers are hardened devices and these are used for holding the work to be held turned between the centers. Not only for the lengthy jobs and also it is used for the work pieces which are to be turned between the centers. For that type of work pieces also lathe centers are used, right? These lathe centers are provided with a standard taper on one end and a 60 degrees point at the other end. How these lathe centers are looks like, because there are some taper on its shape. They are provided with a standard taper on one end and a 60 degrees points at the other end. So, so lathe centers are looks like this. They are looks like some taper shape at one end and 60-degree points at the other end. The center that is fitted in the headstock spindle is called live center. The center that is fitted in the headstock spindle is called live center. As already I told that one center is at headstock side and another center is at tailstock side. The headstock center side is called live center because that center is fitted in the headstock spindle, because headstock is rotated and headstock spindle is rotated. With that only we are getting the rotational movement, right? With that only we are getting the rotational movement. That's why headstock spindle side center is called live center. Headstock spindle side center is called live center, because the spindle is rotated, which is fixed in the headstock. With that spindle rotation, the center which is in the headstock will be rotated. That's why it is called as a live center. And the other side of the center that is used in tailstock spindle is called a dead center, because it is not having any rotational moment. It is only fixed at the right hand side. It is only fixed at the right hand side. That's why it is called dead center, because it is not having any rotational moment, because it is not having any spindle. It is only used for the supporting purpose at the other end. It is only used for the supporting purpose at the other end. That's why it is called as a dead center. So one is live center and another one is dead center. The live center is at stock side, and the dead center is at tail stock side. In between these two centers, we have fixed our workpieces. Right? We have fixed our workpieces. The dead center is only used for the support purpose. The live center is used for rotational purpose. Right? The lathe centers are looking like some taper shape at one end and a 60-degree point at the other end. By this, we are giving the description about the lathe centers. Right? Here the very important points of live centers and dead centers. So we are having different types of lathe centers. One is ordinary center, and the second one is half center, and the third one is ball center, and fourth one is anti-friction ball bearing center. So these centers are depends upon the operation which are going to perform our lathe machine, right? These are depends upon the operation which are going to perform our on lathe machine. Based on that operation, uh, we are using this sentence. Based on the operation, we are using this sentence, right? So we can look one by one. First, we are going to discussing about the ordinary center, and the second one is half center, and third one is ball center. The fourth is anti-friction ball bearing center. So the first one is ordinary center. It is very used for general work. That is, it is having dead center and live center, right? So this is the dead center side center. So it is called dead center side center. That's why it is because it is called as a dead center, because it is fixed in the tail stock. This type of center is fixed in the tail stock. Observe here, that is the center is having taper shape. Here is a taper shape. What is meant by taper shape? Its diameter is gradually increasing or decreasing. So we are already discussed about this. It is having taper shape. It is having taper shape at the other one end and 60-degree points at the other end. 60-degree points at the other end. So that's why it is so the center is looks like this. Okay, and here ordained centers, the dead center is looking like this because it is fixed in the same spot. So it is called as a dead center. And next one is live center. So this is the live center. Why? Because it is called as a live center, because it is fixed in the headstock. That means it is fixed in the spindle. So it is having rotational movement. So that's why it is called as a light center. It is also having a 60 degrees at the other end, at the one end, and a taper shape at the other end. Why? Because it is fixed in some spindle. So we are not getting that. We are not looking that shape, taper shape. So this live center is fixed in the headstock, right? So these are the hardened centers. These are lathe centers or ordinary centers. They are used for only ordinary purpose. That is, ordinary purpose means we are doing turning operations. We are doing turning operation. The turning operation means we are producing only cylindrical surfaces. right? For on long jobs, to fix the long jobs in the check, we are not using the check. We are fixing the two centers. So these centers are one is live center and another one is dead center. These centers are used for ordinary job, that is turning and facing operations like that. And the next one is half center. So this half center is used for taper turning operation and offers minimum wear and strain. Half of the center is ground away here. Half of the center is ground away. Half of the center is ground away. So half center is where this half center is useful for us. This half center is useful for us at this half center is used for at taper turning operation. So in the taper turning operation, when it is useful, can we recall that by form tool method, we don't need this sentence. By compound rest square method, we don't need this sentence. By offset, for offset method or set over method and taper attachment method. For these two methods, we need centers to fix the jobs, because in these two methods we are fixing, we are making tapers on long jobs. We are making tapers on long jobs. That's why for these two taper turning methods, we need this type of half centers. One is taper turning, one is taper attachment method, and another one is offset set over method. For these two methods, we need half centers for fixing the jobs. Okay, so this half center is used for taper turning operations. Ball center used for while facing the job without disturbing the setting. So for facing the job, for facing operations, we need ball centers. For lengthy jobs, we are going to deal with this operation. So here we are providing one ball, right? So that's why it is called as a ball center, and it is used while facing the job without disturbing the setting. Right? So this is the ball center. And the last one is anti-friction ball bearing center. It eliminates the friction and permits work to be done at high speed. Involves with the high work. Anti-friction ball bearing center eliminates the friction and permits work to be done at high speed. Uh, Suppose the workpiece is rotated at high speed, it has to rotate it at high speed, right? Workpiece has to rotate it at high speed, then only we can remove the material from that workpiece, then only the machining process is done properly. We need high speed for that workpiece. So for that workpieces, we are using anti-friction ball bearing center, because if you are fixing your workpiece between these anti-friction ball bearing center, it eliminates the friction and permits work to be done at high speed, right? It permits workpiece at high speed. That's why anti-friction ball bearings are useful for us, right? Now we are moving to another work holding devices. These are driving plate, carriers, base plate, angle plate, mandrels, and rests, right? So centers we have already discussed: live center and dead center, ordinary center, anti-friction center, ball point center. Okay. So now we are going to discussing about the carriers. Carriers is nothing but another name. It is called as a lathe dog, right? The lathe dog or carrier is securely clamped to the face of the plate, right? Here, here one type of holding device, so that is face plate, right? So this face plate, to this face plate, we are fixing this carriers or lathe dogs. About the face plate, we will discuss later. A lathe dog or carrier is securely clamped to the face of the plate. The rotation of the drive plate is transferred to, for transferred? The rotation of the drive plate is transferred to the workpiece through this dog, through this lathe dog, right? So with that we are using this carriers. Use it to drive the workpiece when it is held between two centers. Carriers are used to drive the workpiece when it is held between the two centers. So these are the lathe carriers. Lathe carriers. In this we have fixed the object in this here. In this hole we are fixing our object, and by rotating this dog it is tightened. It is tightened, right? So it is having a bent tail lathe dog. So this bent tail lathe dog is there. Here also bent tail lathe dog, right? So these are directly fixed into this faceplate, right? This tail lathe, this bent tail lathe is directly fixed into the faceplate or driving plate. So by rotation of the driving plate, the workpiece is rotated. Okay, so it is the workpiece is fixed in this lathe dog. So by rotating this dog, the workpiece is tightened here, and the lathe dogs having here a bent tail. This bent tail is fixed on the faceplate. The faceplate is having slots. We will observe in the next diagram. Next. Holding device, the faceplate. This is fixed on the slots of the faceplate. So if the faceplate is rotated, this lathe dog also rotated. If the lathe dog is rotated, with the workpiece which is fixed in this lathe dog, that workpiece is also rotated. Okay, so that's why workpiece is rotated. Here what we are observing the different types of lathe dogs based on our diameter of the workpiece, based on the diameter of the workpiece, different types of lathe lathe dogs, right? So this is the tail, the bent tail. This bent tail is fixed in the face of the drive plate or face plate. It is fixed in the drive plate face plate slot, right? If the face plate or drive plate rotated, this entire lathe dog rotated. The lathe dog rotated, the workpiece which is fixed in this lathe dog is also rotated. So that's why we are getting the motion. That's why we are getting the rotating movement of the workpiece. Okay. The next face plate. We have already discussed about this face plate in the lathe dog. The lathe dog is fixed in this face plate. The lathe dog is fixed in the face plate. It is open slotted circular plate with large diameter. Before going to discuss about these points, we will observe this figure. So observe here, it has a holes and it is having slots, number of slots. In these slots, we have fixed our lathe dog bent shape. One of the slot in this we have fixed the lathe dog. If this place plate rotated, lathe dog also rotated. With the lathe dog rotated, our workpiece is also rotated. Right. So observe these points. It is open slotted circular plate with a large diameter. We have observed the slots on the circular plate, and it looks like a large diameter face plate. And the workpiece is clamped using T-bolts. The workpiece is clamped using T-bolts. In this, the workpiece is fixed by using T-bolts. Mounting work on faceplate provides an ideal way of supporting works which cannot conveniently held by checks. Right? Mounting work on faceplate provides an ideal way of supporting works which cannot conveniently held by checks. Workpieces which are not held in the checks firmly, we are using the faceplate. In this faceplate, our workpieces are held in ideal way. That's why faceplates are used. Okay. Now drive plate. Drive plate is a slotted circular plate attached to the lathe spindle. This is also looks like a face plate. So, right, it is also having a slotted on a circular shape. It is also having a slotted on slots on its circular shape. Drive plate is also a slotted circular plate attached to the lathe spindle. The drive plate is used to drive a workpiece with the help of carriers. The drive plate is used to drive a workpiece with the help of carriers, as I already told that lathe dog is our workpiece is fixed in the lathe dog. That lathe dog is fixed in the drive plate, right? So here the drive plate is used to drive a workpiece. Here we have to use the drive plate or the lathe dog. We have to use the combination of both. We have to use the combination of both. That is, if you want to use the lathe dog, there must be a drive plate. If you want to use a face plate, we must have the lathe dog, right? So with the combination of this only, we are using the we are using to hold the workpieces, right? If we are using the drive plate, we need a lathe dog. If we are using a lathe dog, we need a drive plate, right? The drive plate is used to drive a workpiece with the help of a carrier. That means dog. A lathe dog or carrier is securely clamped to the workpiece and its bent tail fits into one of the slots in the face of the plate, as I have already told in the lathe dog section that lathe dog or carrier is securely clamped to the workpiece. Lathe dog or carrier is securely clamped to the workpiece. The workpiece is fixed in the lathe dog. By rotating the dog, it is tightened, right? And the lathe dog is having bent tail. The dog is having bent tail. This bent tail is fixed into one of the slots in the face of the plate. One of the slots in the face of the plate. Right? So the rotation of drive plate is transferred to workpiece through the dog. Rotation of drive plate is transferred to workpiece through the dog. Right? After here, drive plate. This is also having a large diameter plate and it is having slots. It is having slots. The large slots and small slots. The workpiece is held in lathe dog. The lathe dog is having bent tail. The bent tail is fixed in one of these one of these slots. If the drive plate is rotated, lathe dog also rotated. If the lathe dog rotated, the workpiece which is fixed in the lathe dog also rotated. Uh, so overall, we are getting the rotation of the workpiece in the in lathe machine. We need the workpiece is rotated. We need workpiece should be rotated always. Now we are moving to the hanging plate. Hanging plate provides an efficient means of holding work of complex and irregular shape of which is inconvenient or even impossible to clamp in Georgia. Hanging plates are where we are using hanging plates. These hanging plates are used where the irregular shapes and inconvenient shapes have to fix. For that plates, we are using this hanging plates, right? The workpieces not fixed in the job easily. For that type of workpieces, we are using hanging plates. The hanging plate is attached to face plate and work is clamped to hanging plate. Here we have to compute that we have to attach a counterweights. The counterweights are attached to opposite of face plate to counterbalance the work and angle plate. The angle plate is attached to face plate. Angle plate is attached to face plate and work is clamped to angle plate. And the work piece is clamped to angle plate. Right? The counterweights are also attached to opposite face of face plate to counterbalance the work and angle plate. So this is our angle plate, right? It is having some slots in this here, right? This angle plate is fixed to the face plate at one side, and the other side we have fixed the workpiece. We have fixed the other side to the workpiece, and the angle plate is fixed to the face plate, right? To balance this angle plate, because it is having some weight. To balance this weight, we have fixed a counterweight attached to the faceplate. Counterweight attached to the fixed faceplate for balancing the angle plate. So this is the angle plate line diagram. Observe here. So this is the angle plate, right angle plate. This is the angle plate. So this angle plate is fixed to the face plate, right? The angle plate is fixed to the face plate. So at one end, at the other end, the workpiece is fixed. So this is the irregular shaped workpiece. This is the irregular shaped workpiece is fixed. Irregular shaped workpiece is fixed. So by fixing this angle plate at one end, it is having a weight at this side. To balance this weight, we are providing counterweights on the face plate. So after balancing, it is not having any bent effects or vibrational effects. So after giving the spindle speed, so the face plate is rotated. If the face plate is rotated, this is also rotated. The face plate is rotated. The workpiece is also rotated through this angle plate. When these angle plates are used, wherever the irregular shapes and uneven shapes are have to fix, we are using this angle plate. Now we are moving to the mandrels. Mandrels are used for hollow work jobs. To fix the hollow work jobs between the centers, we are using this mandrels. Mandrels are used to hold and rotate hollow works. Mandrels are used to hold and rotate hollow works between centers. It is a hardened and tapered steel bar with centers on its flat ends. The mandrel is rotated by the lathe rod and cascade, and the work is driven by friction. We are having types of mandrels: solid mandrel, gang mandrel, expanding mandrel, cone mandrel. Solid mandrel is looking like this, and the expansion mandrel, cone mandrel, right? So mandrels, where the mandrels are used to hold and rotate it hollow works between the centers. The last one is the rests. So provide additional supports for long workpieces. We are we have discussed that for the long workpieces we are using these centers. The workpieces are held between the two centers. One is dead center and another one is live centers. And also the rests are also used. The rest is also used. What is rest? It is the additional support for long workpieces. Rests are additional support for long workpieces, right? So, so these rests are between the two centers. So anywhere between the two centers, we are fixing these rests, right? It helps to prevent the deflection of workpiece under the action of cutting force of tool. Helps to prevent the deflection of workpiece under the action of cutting force of tool, right? If the workpiece is rotated between the centers, the lengthy job rotated between the centers, if any deflection is there while doing the cutting operation, to prevent that effect, to prevent that defect, we are using rests to support the workpieces. The use of rest is recommended where the length of workpiece is 10 to 12 times the diameter. When we have to use this rests where the diameter of the workpiece is, where the length of the workpiece is 10 to 12 times of the diameter. So we are having different types of rests: study rest and follower rest. So this is the study rest, right? Study rest and follower rest. Study rest is fixed at one place; it is not moving it another way while doing the operation. Study rest is clamped on the bedways in the required position where we need to, where we require this study rest. We are fixing our rest between the headstock and tailstock. Used when a long piece is machined or drilled at its end by holding the job in a chair. It avoids chances of reflection of job at the other end. Study rest. Follower rest. It is mounted on the lathe saddle and moves together with the help of the carriage. It performs the same function as the study rest, but it has the two jaws which support the workpiece upward opposite to the tool. Right? So these are the some of the work holding devices. What are those? Types: carriers, drive plate, face plate, angle plate, mandrels, and tests. For this, we have concluded the work holding devices. Right now, we are moving to the tools and what it is have the tool signature, what the tool is having different types of angles and different types of radiuses. That should be discussed in the next class. Right? I am closing today's session. Thank you.